Hi, I'm Chris Colson, and I'm going to show you a quick example of how to use the semantic kernel. So I guess first, what is the semantic kernel? Really, it's Microsoft's version of LangChain. It's considered an AI orchestration SDK, which means it lets you compose solutions by combining large language models with several different components like native code and private data. So this can let you build solutions that large language models can't accomplish on their own. For example, if you want to have an image generated, an LLM can't do that by itself. But the semantic kernel could be used to have the LLM generate a really good prompt for you, and then take that prompt and use it against Stable Diffusion to have the image generated, and then it could return the generated image to you, the user. So how does it work? Well, it works by combining the LLM with a few different components. First one being native plugins, which are just plugins that run native code. The semantic kernel already has a few built in for doing math, file I/O, and HTTP requests. They've also got semantic plugins, which are essentially just text templates that can be used to have the LLM generate a more exact response to the user's request by giving it more detail and asking for the response in a certain output format. There's also connectors, which are considered semantic kernel's memory. These are connections to external services. For example, there's a built-in Microsoft Graph connector that lets you search through your Office 365 documents. There's a Bing connector so you can search the web. And there's a cognitive search connector so you can include private data that you've got stored in a vector database. And finally, there's planners. So what planners do is they tell the LLM the user's request, as well as describe the plugins and connectors available to it, and it actually asks the LLM to come up with a plan in an XML format that can be understood by the semantic kernel. So then when the LLM returns with the plan, the semantic kernel can actually run the plan and execute the user's request. Okay, now I'm going to show you the semantic kernel in action here. So I've got the semantic kernel documentation project open here, and it's got several examples. So I'm on example number 11, the planner. So what this example shows is a user asking the question, if my investment of $2,130.23 increased by 23%, how much would I have after I spent $5 on coffee? So if the user asks this directly to an LLM, there's a good chance they get a wrong answer because LLMs are not very good at doing math. So what this example here does is it combines a math plugin with the planner to come up with a plan to actually do the calculations using the math plugin. So I'll show you the math plugin right now. So it's pretty simple. It's just a class with several different math functions. Like square root just runs the .NET square root function on the input. It's got functions for add, subtract, multiply, divide, and they're all pretty simple. They just take the input and do the actual operation and return the value. So the only real difference between this class and a regular class is that it's got a bit of extra metadata that gets sent to the LLM by the planner. So it says what each function actually does, like take the square root of a number, or add two numbers. It also describes the parameters needed to run the function, like the first number to add, the second number to add. So all this information gets sent to the LLM while trying to create a plan to solve the user's problem. So I'll go back to the program now and just go through it quickly. So first thing, it just imports the semantic kernel and the semantic kernel planner's namespace. Sets up logging here. Initializes the semantic kernel. Imports the math plugin that I just showed you. Initializes this sequential planner, which is just a built-in planner. And it runs the create plan async with the user's question, And so what this does is it actually asks the LLM to create a plan to solve this, using this math plugin that we imported. So then it once the LLM returns with a plan in an XML format, it just displays the plan on the screen, and then the semantic kernel knows how to run this XML formatted plan. So it actually executes the functions described in the plan using the math plugin, and then it outputs the results. Okay, I'll run it right now so you can see how it works. Okay, so here's the output. It outputs the plan, which looks like it's 2 steps. So first step, it runs the multiply function from the math plugin, multiplying 2130.23 with 1.23 and outputting to an increased amount variable. Second step runs the subtract function from the math plugin with the increased amount variable from the previous step and the value 5. And then it outputs that to the result final amount variable, and that's the final output of the plan. And then just prints out the results of the plan, which is 2615.1829. And if we calculate it with an actual calculator, we should be able to verify that it's correct. So 2130.23 times 23%, 1.23, gives us 2620.1829, but we spent $5 on coffee, so minus 5 gives us 2615.1829, the same value returned. So it worked well. So now I'm gonna add tracing in here so you can see how this is actually working behind the scenes. I'll run this again. Okay, so the first thing it does, you can see it imports the math plugin here. Here's all the functions found in the math plugin, and it's also displaying the basic template for the sequential planner. So this is what actually gets sent to the LLM. So here, create an XML plan step by step, satisfy the goals given. Here's the available functions. Here's what you should do to create a plan. Here's the format the plan should be output as. To call a function, do this, don't do this. Here's some examples how to call the plan, and then the actual goal that needs to be accomplished by the plan. Okay, so I think it's just outputting that again. And so here's what it's actually sending to the LLM. So it's that template, but now it's been filled in with the math plugin, functions and their parameters. Still the rest of the instructions on how to do this, and then the goal, which was the user's question. Okay, so then it returns that plan, and we print it out here, same as we did earlier. And then the semantic kernel actually runs the plan. So you can see it's running the multiply function, it's running the subtract function, and then giving the actual output. So that's how it works. Okay, thanks guys.